Hey, good morning and welcome to this morning's webinar brought to you by Desco Europe. The webinar today is measuring resistance in an ESD protected area. My name is Vaughan Callan and I'll be presenting, and off camera assisting me is one of our regional sales managers, Tim Hacker. The webinar is going to consist of both PowerPoint information and also some demonstrations. Now, we do welcome your questions, and you can see on the screen here there is various ways that you can ask it. Depending on which platform you're using will determine how you can enter your questions. So please, if you have any questions as you go through, please type them in, and we will take a break at the end to answer those questions that we can. And there'll be probably some questions that we'll have to answer in more depth, which we would follow up with afterwards. And just to let you know that everybody who's in attendance today will receive a recording of today's webinar. So we have various resistance meter types in our lineup, but today we're going to be using the digital resistance meter. This is the most accurate and the one that fully conforms to the European standard, as this also makes note of relative temperature and relative humidity. So the digital resistance meter is the one we're going to be focusing on today, but you see there's other meters there that we're very happy to conduct any future online one-on-one virtual demonstrations. So we'll go through the resistance measurement requirements for an ESD control plan. And it says here tips and techniques. Well, that's where we'll actually do some demonstrations to show you how to use the digital resistance meter. The two most common types of resistance measurement are resistance point to point, and the abbreviation of that is RPP, and the resistance to ground, which is RG. There is one other, which is RGP, which is resistance to grounding point, which we will also cover as we go through this morning's webinar. So the first table we're looking at today is looking at how you would use the digital surface resistance meter to test for product qualification and compliance verification of a wristband. Now, product qualification, when we talk on those are the tests that you would do when you're qualifying a product before you put it into use. And the compliance verification is the testing that you will do once a product is in place, and the testing that you will need to do. So what we'll do, first of all, we'll switch to our overhead camera so we can show you the first test that we're looking out for, which is the product qualification for the interior of a wristband. Now, what I have here is our digital meter, and I'll just turn the meter on and you'll be able to see it. When I'm taking the readings, I will lift it up to the camera so you can see. And attached to that with the leads, we have our 2-point probe. So the first test that we're going to do is measuring the interior of a wristband. And the European standard is calling out for that test to be less than 1 × 10⁵. So I have a wristband on the work surface here. What I put is a piece of insulative plastic, just so we don't pick up any residual current from the grounded work surface. So if I place the 2 probes on the inside of the band, and they're sprung loaded, and then we push that down to make good contact, and then if I hit the test button, and then we wait for it to come, and we've got the reading there. And what we're looking for is a reading of less than 1 × 10⁵. And as you can see on the meter there, we have a reading of 1 × 10⁵. So the interior of the wristband is perfectly within specification. The next test that we call out for on the wrist strap testing is for the exterior. And what we're looking for is a reading on the outside of the band to be greater than 1 × 10⁷. So again, using the spring-loaded probes, we push down onto the exterior of the band, and once again we push our test button, and then we just wait for it to stabilize, and we'll get a reading. And as you can see here, hopefully you can see that that is 2.555 × 10⁻. So we can see that the exterior of the wristband is within specification. So the next test that's called out for is the compliance verification test, and that is for the continuity of the wristband. So that's a wristband when it's actually in operation. So what we will do with this one, to do this test, we will plug the wristband, the digital meter into a ground reference point, and take the other lead, we discard that for a minute and put that into the probe here, the hand probe. And then if I take my wristband, place it on my wrist, as you can see here, and then if I take, whilst holding the probe, if I again push the test button, we're looking for less than 3.510.7, so less than 35 megohms. So whilst holding the probe, and there you can see 5.01 times 10.6. So once again, the meter is checking the verification and the wrist strap continuity test, and you can see that this particular wrist strap is within specification. So that's another test that you can do using the digital surface resistance meter. So what we'll do now, if we go back to my PowerPoint, just to show you the testing that we're going to be conducting. So everything that's within the green boxes are what I'll show you that we can the testing that we can do using the resistance meter. So the first one we're going to look at is the product qualification for a working surface, or that could be a storage rack or even a trolley. And there's two tests that are called out. The first test is the resistance to grounding point. The second test is the resistance point to point. So once again, if we go back to our overhead camera, if I just get my leads untangled, and to do that, the first test called out for is resistance to grounding point. So that would be a test from a point on the work surface to a grounding point, which we have over on the side of the workbench. So I plug one of the leads into there and one of them into the resistance to the grounding point on the work surface. Turn the meter on once again, and what we're looking for is a resistance to grounding point of less than 1 times 10.9. So it's the resistance we're putting the voltage through here. It's going through the surface to the grounding point, and once again pushing the test button. And we can see here, hopefully you can see on the camera, it's 9.40 times 10.5, so well within specification. The other product qualification test that is called out for is the resistance point to point. So if I just bring in the other weighted probe here, plug that in. So now what we're going to do is a test, and we're going to test between 2 points on the work surface, and that's where we have the probes. And each of these probes are within the European specification of 2.5 kilograms each probe. And again, hitting our test button, and again we're looking for less than 1 times 10.9. And there we have 1.71 10.6. So we're very comfortable to know that this work surface meets the product qualification requirements. Then if we move excuse me, if we move over to the compliance verification, this is the test that you would do once the work surface is in place. And to do that, you would do the resistance to ground. So that would be from the point where this probe is into where the product is grounded. And this is our grounding point back here. If I plug that in, and once again, we'll be looking for less than 1 times 10.9. So there we have 1.97 10.6. So again, we're able to determine using the resistance meter that this particular work surface meets both the product qualification and then also the compliance verification. You'll see further down that we have the flooring. Well, the flooring test is exactly the same as you would do on a work surface. The only difference is the European standard does not call out a resistance point to point between 2 points on flooring. So you would just do the resistance to grounding point and the resistance to ground. And both of those, again, like the work surface, the requirement is to be less than 1 times 10.9. What I'll do now is I will switch to the other camera, because what we're going to look at now is the test that we will do now is on the seating. And so if I just move this, and if we go to the other camera, and I've got the chair here. So the first test that's called out is the resistance to grounding point. And with a chair, the grounding point would generally be the floor that it's sat on, which would need to be grounded, or a mat. So we would place one probe onto the surface of the chair and one probe onto the floor. Now, I know what is going to happen here, but just so I can show you, because what we're looking for is resistance to grounding point of less than 10.9. So again, if I push the test button, and I'll bring it as close to the camera, I'm looking to see if it's coming up on the camera. This is about as close as I can get it. And what I can see here is straight away, this is going to be greater than 1 times 10.9. And that's deliberately done because this is for testing of seating. And then what I've deliberately brought into today's webinar is a non-ESD chair, just so I can show you that a test, if it doesn't test this, if I just hit that button once again, you can see, but what we can see up here is it's already greater than 10.12. And if we just wait for this to stabilize, it should actually give us an exact region, unless it's just too far off the scale, which it is in this case. But what we'll look at here is it's greater than 10.12. So I know that the meter is doing its job and telling me that this chair is not in specification. The other test that it requires is resistance to ground, and this floor and everything in our demo area is all grounded back to the same point here. So once again, I place one of the probes onto the work surface and one into our grounding point, and once again doing the same test. And what we will see, I'll just move, sorry, I'm just going to move around a little bit so you can hopefully see it a little bit clearer. And what we're going to get is exactly the same. We're going to see that it's out of range. It's going to be greater than 10.9. In fact, it's up at the 10.12 range. So we know that it's out of spec. So that's why I deliberately brought in a non-ESD chair, so you can see what would happen when something is out of the range that we're looking to test. The other medium that we can test, the other product that we can test with our surface resistance meter, if I just untangle my leads here a little bit, is garments. So what I have hanging here, if I just move the chair out of the way, what I have hanging here is one of our ESD control garments. And what you were looking for here is a resistance point to point. So when testing a garment, you would test from one sleeve to another sleeve. And what I've done here is I've got some crocodile clips attached to each sleeve. And if I plug the leads into those, like so, and then do my test once again, I can bring this a little bit closer to the camera, holding the test button. And what we're looking for is resistance point to point of less than 10.11, and what we have here is 5.62 times 10.6. Okay, so that's in specification. Now I've used crop clips to do that. What you can use is if you put your jacket onto an insulative surface, you could put a weighted probe on each sleeve, attached with the leads to the meter, and conduct the same test. But just for today's purpose, I've used the crop clips, but the other way of doing it is to use the weighted probes. There is one more test that's called out for if you have a smock that has a grounding point, okay? And that is, if I take my crop clip here, Plug this one in. I'm sorry. Let me use this one. And on the side of this particular jacket, we have a grounding point. So these jackets like I'm wearing now, you can actually wear your grounding cord to ground the operator at the hip instead of having to use a wristband, because the wristband is actually built into the jacket. And once again, the test we're looking for is the groundable jacket there, and you can see down the bottom there it needs to be less than 1 × 10·9 for both product qualification and compliance verification. Again, bringing it into the camera so you can see, hitting the test button. And we have 5.70/10·6. So once again, within the confines of the requirements of the standard. So this just goes to show you some of the testing that you can do, but there is some more that we're going to come to in a little while. But if we go back for a short while to our PowerPoint. So the other testing that we that you can do is on packaging, test packaging. And there's two. What I've done is I've highlighted the 2 areas that we're going to look at, which is using the 2-point probe for resistance point to point, and also using a concentric ring probe. Now, what I'll do is I'll just move those 2 weights to one side, bring in the concentric ring probe. Now, what this does, a concentric ring probe, because if you're testing with, a small bag or something like that, then the 2 probes, you maybe not have enough space. So what we have on the underside here is this 2 probes that's wound in here that simulate the 2 separate probes. So to show you how that would work, what you can do here is, again, using our leads, plugging them in. If I place I'm just going to put the bag onto an insulative material so we're not picking up any residual charges from the work surface. Place the concentric ring probe onto the bag and hit our test button. And what this will do is verify that this is coming in at 7.3810·3, which is in the conductive range. A further test you can do using the concentric ring probe is if I take one of our shielding bags. So as well as testing the exterior of a shielding bag, and you'll see this will come up as a very different reading to the conductive bag. But once again, with the ring probe, the concentric ring probe on the outside of the bag, hitting our test button. And you can see we have 1.93 × 10·8. So this is a dissipative bag on the outer as opposed to the conductive one. The other test you can conduct is the interior of the bag, and that's very simply opening the bag up, placing the concentric ring probe on the inside of the bag, and you'll see we'll get a slightly different reading to the outer. And there you have 6.33 × 10·8. So that's perfectly showing you how you can use the digital meter with a different adapter on the end of different the 2 probes or the 2-point probe, using the concentric ring probe to test the bags. There's the other test that is shown on the PowerPoint presentation there is, again, using the 2-point probe. So if I take those back in, plug that back in. Now, if you have a very small bag that you couldn't even use a concentric ring probe for, or you have a conductive box like this and you can get smaller ones, again, we can use this to test the box. Again, placing it on top, pushing the spring-loaded prongs down, hitting our test button. And there we can see that the This is reading at 3.35, 10.7. The other test, again, what we can do if we open the box up, and you can see in this particular box we have a conductive foam on the bottom and an anti-static foam in the top of the lid. We can test the interior of these, so we couldn't get one of the bigger probes inside. So we can test the conductive foam at the bottom of the box, and you can see once again it's coming at 2.0 times 10.3. So again, you can see that's conductive, and that's exactly what it's meant to do. And then if I just do the same test again, but on the pink dissipative or anti-static foam in the top of the box, and you'll see that's coming in at 3.90, 10.9. So once again, in the anti-static dissipative range, perfectly within specification. So what you can see is that this meter, these digital meters or the surface resistance meters can conduct a lot of tests that are all called out for in the European standard. So as you can see on your screen, there's a lot of words on there, but as I said at the outset, we will be sharing this PowerPoint with you and a recording of this to all those who have attended. So just to go through some of the points of the meter that we've been using today, it's manufactured in one of our facilities in California in the USA, and is serviced and calibrated here at our facility at Letchworth in the UK. And as you saw there, when you push the test button, there's a stabilization mode. That mode is to enable us to record the relative temperature and relative humidity, and a stabilization period is required of up to 16 seconds to make sure the reading is accurate. As you can see in the drawing there, it does come with, although I didn't use them today, it will come with spacers that you can use to make sure that you've got the weighted probes spaced accordingly to get the optimum reading. You saw, hopefully it came clearly on the screen, you have a large OLED display, so it's easy to read. And at the very top, you've got the exponent LEDs for quick checks. Now, remember when I was doing the chair test, and I pointed out that it had gone over to the very top right-hand side, which is greater than 1012. So that was just a very quick test. So you're able to ascertain whether something is likely to be within specification within the verification period, or the stabilization period, rather, sorry. This particular meter also has an internal memory, and it enables you to store and recall up to 100 measurements, and that's both resistance, temperature, humidity, and the test voltage. I'm not sure if I made it very clear. I'm not sure if it covers it. Let me just go back a couple of slides. Sorry, I'm going the wrong way. Apologies for that. As you can see here, if you're looking at this picture here, this one's showing, and you see in the top left, 100 volt. What this meter will do, this will auto detect whether it's a dissipative material or a conductive material. If it's a dissipative material, then the test voltage that you require is 100 volts. If it's a conductive material, the test voltage will be at 10 volts, and the digital surface resistance meter will auto detect what the material is and put the right voltage through the test. So what we're able to do is, this is an overview of the testing requirements. If anybody is interested in having a virtual demonstration of any of our resistance meters, or indeed any of our products, but as we're talking about our resistance meters today, all you have to do is let your inside sales contact know, and we will organize a virtual one-on-one online demo. So what we're going to do now is we're going to go and see what questions have come in and see if I can do my very best to answer those. So I can see that I'm just having a very quick look through. And one question is, do you have to test the back of the chair for compliance verification? No, you don't. It's the seat, it's the seating part that where the operator makes intimate contact here, because if you can imagine, you can't see me on the camera at the moment, you can imagine that some people will sit and they won't rest against the back part of their chair. So it's really the seating part of the chair that you would need to test. Someone said, saying anti-static, do you mean in charging? Yes, that's exactly that's another terminology that is used. So we have conductive, dissipative, low charging, and anti-static. We've got some other questions that I'm just looking at, those that are going to actually require us to get back to you with a more in-depth answer to your question. So rather than me give you a quick answer now, then we'll get back to you. I mean, we've already received requests from a couple of people to say they need help choosing the right tester that they need to do, and obviously we'll get back to you on those. So if I haven't answered the questions, we didn't have that many. I'm just trying to scroll up to see if there's any more that I've missed. No, that's covered that. To say there are some that need more in-depth answer. Someone has made the point the back of the chair is the closest thing to the desk when someone isn't sitting in the chair, and if it's an ESD safe and exposed to the desk, it needs to be compliant too. Okay, that's maybe a fair point. I guess I was looking at it for in situ with the person on it, but I guess if you need to, if the chair is going to be pushed against the working surface and no one sat at it, then yes, it could be needed to be tested to make sure that that is compliant also. So apologies and thank you for the correction, Susan, for correcting me on that. But so yes, you would need to test in that scenario both the seating area and the seat back. So with that, I would just like to thank you once again for attending today's webinar. You can contact me directly or your inside sales contact to answer any questions you have, and as I say, rest assured we will get back to you with more in-depth answers to those that we didn't answer today. Once again, thank you, and I wish you all a good day. Thanks.